Okay, so I'm back. We crashed. I think that the sound was a little bit low, so I am increasing the volume. It should be better. Okay. Okay, let's go back. So this is our ledger, and I was saying that before writing the code for the module, we need to actually define a version number and define the name of the module and a description for the module. That's part of the standard. Okay, so the next thing I want to do, this time it's really defining all the types. So regarding the ledger, we have different type. We have the types transaction. This is the first one. No, sorry, this is here actually. We have public type transfer, mint. We also have the type of the ledger itself. So a ledger should be an actor where we can do those things like the transfer and the mint. Ledger transfer mint. And then we have to define the state. So taking inspiration from this, we have two types of state. We have the root state and the leaf state. So this is the root state is the state that will be stored inside the root canister. So the root canister is, in our case, the kernel, the God canister that we have defined here. So this one. Let me zoom a little bit. So this one. And the leaf will be all the players. So all the players are considered leaf. I could call it maybe like kernel state, or like, yeah, kernel could be something, but I like the root and leaf. I think that's also more generous, like something we can generalize easily, and I could see that being some type of pattern. So root state and leaf state. So root state, we will store the ledger, I mean the actual like balance. So this is how we've done it. It's principal and not. And here I need this module to import the map module, which is imported like this. And for now, I mean, the leaf state doesn't really have any, well, there is one thing that the leaf needs to store, which is the root. And it also always needs a reference to self. Yeah, you will understand this self thing. It's actually because when you have a module, when you have a module, you always need to pass the canister ID that is going to use this module, because you can't access inside of your module, you can't access like the principal from actor. So you need to store it somewhere, which is, I store it inside of self. This is something that is very recurrent. Okay, so the leaf is just going to store a reference to the root, and it's going to store also the principal of itself. And the root, this is where the ledger is stored, so where the actual balance are stored, and that's about it. Yeah, we don't need more for now. Let me just check. Oh yeah, and we need a function that is going to init the root and a function that is going to init the leaf. So we can call that public function init root, which will take only the self as an argument, and it will return this type, which is memory.state of the root. And So what is this? Well, this is the memory that we import from the utilities. It's one more, I think. Yeah. Remember, we have this file, which is defining the type memory. We are importing this module, which is the memory module. Actually, I called it module memory, but we could call it just memory. Yeah, actually, it's cleaner like this. I think it's, yeah. Okay, so memory. And then in the memory, we want to import the type state, which is this one. And then this type is defined by another type. I mean, we have to pass this S type, which is a generic type. And in that case, it's the root, so this type. But we are going to use also the leaf. So init leaf like this, self memory.state leaf state. And we just need to return the instance of this type. So here we can do it like this. Root state. Yeah, we need to make that variable. So we can change it later. And this will be variable ledger is equal map.new. And variable self will be self, the one that is passed here. There is something missing. Oh yeah, we need to use the memory.init. Actually, like this. So this memory module, it's just a way to standardize how we access memory. I know it's a lot of like syntax that we have to add, but you will understand when we finalize it, like when we finalize this module and when we use it, how clean the use look like how clean it is to use and to actually come back and modify your code. So it's really, really, really cool in the end. And once you understand like the syntax, it's really not that much. Okay, so now we want to do the same for the leaf. So the leaf is root, and actually the leaf needs one more parameter, which is going to be this one. Okay. And I think we're pretty much done with this for now. Yeah, we're pretty much done with it. Okay, so now we can move to the actual code of the module, because this is just the state. So we just store the state here. I mean, we don't really store it here, but we store it in the main.mo in the end. But we can access the init function here, and that's pretty much all we need. When we want to upgrade to another module, we will need to add an upgrade method here, but that's for later. Okay, one of the thing about this standard is that we have to use this to define the version of the module. So this looks a little bit weird, but what we're doing is importing version 1 from what we've just done, which is the state v1 We don't need the .motoko, we can just do it like this. Actually, it's like this, yeah. So we import the file that we've just defined, the v1.motoko, this one. And then we define this module, which is the state. So this is a module inside of a module, but it represents the state of the module, like the memory of it. And we define this v1 of the module, which is the version 1. If we want to upgrade, we will have to do v2 and then version 2, and we will have to import this from another file. But for now, we have only v1. Then we also need to define some error message, like generic error message. This is for the module. I like to do that. So error in ledger. This is a prefix that I put to every single error message in that module. So now if I have a problem later when I use that module, in my canister I will see error in module, and then I will see the error. So that enables me to quickly know where my errors are coming from, not like any random line or any random module. And then we can import the types. So all the types that we have. Hopefully at some point we can get this type of syntax to be automated, because it's very repetitive. It's going to be all the types that are defined in the file. We just import them. So root state, version 1.root state, leaf state, okay, so this. And then we define a class which is going to be used by the root, and a class that will be used by the leaf. I could call that like God, and I could call that player. The reason I'm not doing it, I'm not sure why I'm not doing it actually. This idea of like root and leaf. Well, the thing is that I'm trying to build this standard, and I don't think that all the time it will be this combination of root and leaf. I think it will generalize to any type of combination. So yeah, I think the root and leaf is kind of a good direction for now. We can always change it later. So we can initialize a class with the memory that is already out there, because we will not start from 0 every time. We will keep, of course, the state that we already have, if we already have something, when we upgrade. So every time we upgrade, we are going to reinitialize the class, but we will do it with some memory if it's the first time we initialize it. But if there is already something stored, we don't. And that's actually what I will do here with this. So this is also part of the standard. The first thing I do in any class is memory.load, and yeah, we need to pass again the type, and we do that inside of stored. What this does, again, if we look into utilities, utilities memory, this one, what this does is that this look at my state, so whatever I have in memory. If I have nothing, that's weird actually. If I have nothing, it just trap. Yeah, because we need always to pass something, even if it's the initial value. So yeah, that's pretty normal. This will be used from the main Motoko file. And then we have the leaf, and we can do the same. I mean, we have some code here to do, of course. but we can do the same for the leaf because it's the same pattern, just stored memory.state leaf state. And there is a typo here. Okay, cool. So now what we want to do on the root, we want to implement the functionality that we had previously implemented in the main.motoko. So if we look at our god main.motoko, what we had here is that we had implemented everything inside the body, but we don't want to do that. We want to do it here. So the first thing that we want to do is public function mint, and we are going to pass the mint parameter, so mint, and then we just return. And it doesn't need to be async here, it can just be synchronous because this will be called from the main. And actually we can just repeat the same process. So I would like this prettier to work, that would be great. Well, it's telling me that it's formatting, but it's not formatting anything. Because I don't think I define it correctly, actually. Yeah. Base option. Maximum supply, I need to define it. And this, I'm not sure if it should be part of the V1 or the V2 or the code. Well, this should be state.ledger. We need to import this as well. The maximum supply. So the maximum supply, I'm not sure if it's part of the code or if it's part of the... Yeah, that's interesting question. I think I'll just put it here for now. But yeah. That might be something that we actually want to make part of the version. Like, I mean, the maximum supply should not change. This is not something that we want to change, but at least for this ledger. But there might be, yeah, I don't know. There might be some advantage to put it in the V1. I'm not sure yet. Okay, so state.ledger, and yeah, we can actually make that a thing, so we should be able to throw error. I'll make it async star. Why isn't prettier working for my Motoko file? That's super annoying. Like, it would be so cool to have it. I think that's where the problem is. Oh shit. Let's see. Yeah, actually I did not install anything here. I don't even have a package.json, so yeah, makes sense. Okay, now it should work. So if I go back to this, fuck. Why did it disappear like this? Do I have the Motoko extension still? Yeah. Okay, I have it, so. Okay, so definitely looks better with this enabled. Okay, so let's see. Okay, so yeah, now I'm not sure if who is formatting my code now. Is it the Motoko extension or is it with the Prettier plugin? Works out of the box with the Motoko extension, compatible with the Prettier extension.